Hello, good evening, good morning, whoops, depending, oh dear, that's not very clever. Continuing the theme from this morning, for those of you that are in the States, on the north, on the American continents, and west of here, beep, 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 beep. I've got my new visualizer, just opened it up, so it's going to, I've now got to find out how another new bit of technology works. I am an electronic engineer. In theory, I'm the one who would actually have been designing things like this, but oh look, if you had two of them, you could make a heart. That's where my brain goes these days. So that'll be interesting. And I was like, well, how do I plug it in? I found this little hole there, so I've found the cable, nearly threw it out. I had to dig underneath everything and found there is actually another cable to connect this to the computer, and let's see how the visualizer works. It'll make life a bit easier for doing what I'm doing right now. So today we're continuing with what we did this morning, so we're going to do more or less the same. We've done this before, but you probably weren't here, and even if you were, what the new style of these sessions is, we have ways and means of making you talk. There you go. The new style of the session is that I'm going to make things at a pace where the young people can participate. So we had a great success with this morning. We had one parent who, the lovely Kate, that they didn't watch it. They were having breakfast when it was on, and then later on when she was doing her work, the girls were rewatching the live. So please do tag other people. If you're, it's not that early, I know, but maybe it would be over lunch or something. Depending where you are, well, I suppose parts of the States it's already, well, in the afternoon anyway. So what we're going to do is we're going to do tangrams again. I know some of you might have done tangrams with us, but we're going to do them more slowly, take our time, and have the opportunity for, if I can manage to, without the visualizer yet. And I'm just going to share it quickly as well. Okay, got that one there. Got to find it on here, then share it. That's how it kind of works. Yeah, go there, and then there's the live. Yay! There's the live. 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 And share. And share to a page. You're going to share it on the Bubbly Maths page. And tangrams, let's call it tangram stories, because you're going to be telling stories about tangrams, or you can be creating art, and the other one's going to be over on there. So we're going to share, oh, I've changed my profile picture, and I forgot about that. That was hours ago. Ooh. And that's going to be, okay, tangram, well, it's tangram art, I suppose, actually, really more than tangram stories. Share it on there, and then I've worked it out. What you do is I can share it. Yeah, that's probably all I need to do, and then later have a watch party. Have you discovered watch parties? Anytime you want to share these things, if you want, you can have a watch party. So if you're seeing it later, if you're watching this later on and you want to share it with your friend, just click watch party, and then other people that you want to see it, it'll come up as your lives, and what I'm saying now will appear for them. It's like a movie playing, and you can all be watching it at the same time and doing the activity at the same time. So have a go at that. There's also, slowly but surely, all of these things have been put up on YouTube, which means that you can go and view them again on YouTube, and that's the Bubbly Maths channel on YouTube, and there's the Maths Toys channel on YouTube, and then there'll be links to actual resources for parents. The ones for parents are being created. There's ones for teachers that are aimed at teachers in disadvantaged communities in Africa. And so that they are easy to understand because the teachers, it's not as though they have the two-way communication to ask questions and whatnot. They have to be really clear and easy to follow. So those are still very useful for adults. It's a lot of helpful things like good questions to ask. So the best answer to any question is not an answer, is not this is how, an explanation. It's another question. So we're going to just dive right in. Now this morning I decided when I was doing the ones this morning that I wasn't going to, here we go, I wasn't going to use scissors. I thought, well, the new format, this was by request, oh dear, is this going to work? The new format was, could you please do something that kids can watch without necessarily having adult supervision? Well, then I'm literally lying awake thinking, oh dear, now what if I could say scissors and I don't know who's watching? So at the moment I decided I'm just going to use a technique for not using scissors. So the first thing was, and this was a surprise for me, that not all children know how to make a square, which is a big surprise for me, although those that do immediately made that little game that you play that count to whatever number and they open it up. So those that know how to make a square know about that one. But those that don't, not even every child knows how to make paper airplanes. So I probably will actually do some paper airplane sessions doing the maths of paper airplanes because, oops, don't want to fold that one too much. So it's literally folded in half. Sorry, not in half, but across the diagonal, folded down to the opposite edge, nice and neat. Then this is the bit we don't want because this is now two halves of a square. So we're going to fold this over nice and neatly right along that line and right up this edge. So it's nice and precise and not perfect yet. Will it ever be perfect? Maybe not. But here we go. And there we go. Crease, crease, crease. Fold over. Crease some more, crease some more, crease some more. Now what I'm discovering is it's actually a lot harder to cut this when you've got a tight angle like this, but so far it's okay because we're starting off with 180 degrees. And a nice technique is to get a ruler, place it down and rippity rip. You can actually do that without scoring it. In theory, it's better if you have a metal ruler, but it's not as reliable. If you get well practiced at it, it works. Right, so now we've got two identical triangles. We've halved the piece of paper so the area is half of each. And we're now going to make our tangram, we're going to find the center point. So to find the center point, we're turning it round and joining those two opposite edges. And this time we're not going to flatten it down, keeping that curved, but we are going to flatten down just the point where they cross-sect, and that is our center point of our triangles. If you need square, so if you need to find the center point of a square, that's how to do it. And you can do exactly the same technique to find the center point of a circle. Fold it in half, open it up, and then fold the two folds together, and then crease it at the center point, and that will be the center of your circle, which is also useful for making other geometric shapes, which we will make. Right, so and now this can be of use to very young children. We had a 5-year-old, we had children, people in school, we had between the age of 5 and 15 this morning. One was doing his GCSEs and one was just starting out with his school career. So he was working with his mum, but I haven't heard from Daniel yet, so I don't know what he thought of it. But this is just as useful because when you're doing your GCSEs, your exams that you do when you're 15, 16, wherever you are in the world, you need to know about angles and geometry, and it's usually on a 2D piece of paper with a picture And you might have a ruler or a protractor if you're lucky, and a compass, but it's all very cerebral. It's not manipulative. Whereas you start doing things like this, you can start playing with angles and you can actually create them. So we're going to see how we create a few of the shapes that we refer to in school. So the next thing we're going to do is, you've got the fold, take the opposite end, we're going to fold it right, have the tip in the center point, right there. So the center, hold that nice and tight, pull that out and give it nice firm. I'm going to give it a few goes round. Whoops, have I moved the camera? Did I move the camera with the... I don't know. There you go. I'm going to see if anybody's on here. I've got you on there. That's the live on there. Have I got anyone on the live on here? And is it indeed live? Who knows? Anyway, keep going. And get the ruler out and very firmly there we go. We now have a triangle. So we got rid of the rectangle, the oblong that we started off with, but you can still make lots of little triangles with this. In fact, you can make more squares. The scale, the proportions will be the same on this one as they are on this one, I'm pretty sure. Yeah, because the angles, yeah, because that's 90-degree angles, and that will be, yes, it will. Just make sure you haven't done like I've done there. That matters. That much of an error matters. You're not going to actually have quite the same proportions, so you really do need to be quite careful. So you can make, if you want to make art and not a tangram, then you can, the thing about the tangram is you only have certain shapes, and with those certain shapes you make other shapes. But if you want to make art or just be creative and make loads, you can make lots more triangles with this and cut them out. And then you can scale it down again, get rid of that bit at the end, and then make lots of triangles with that, and just make lots of different size triangles and do lots of art like that. So with our tangle, we now have a shape that we can look at, we can name it, we can count how many edges it's got, and have a conversation about that shape. Because a lot of people think a pentagon, young learners, has to be a certain shape. In other words, a regular pentagon, and not only that, that it has to sit on its base, and if it isn't sitting that way, it's the same with a, not so much a rectangle, but with a square, it has to be sitting that way. And perhaps a rectangle as well, either has to sit up that way or that way, but no, it doesn't matter which way it goes, and that's the great thing about manipulating with paper as well. You can see that no matter which way around it goes, it's still the same shape. So this one, we can have some fun with that. Maybe a sailing boat, or it could be, it worked out earlier, it could be the start of an airplane. This, we are going to fold it in half now. We're looking at symmetries. How many ways can you fold this piece of paper in half so that the two halves are mirror images of each other? Can you find any other ways of doing the same thing? So how many ways are you able to do that? How many ways are you able to do that with this shape? Fold it in half. And you can play around with symmetry like that, and you talk about mirror symmetries, and this is the axis of symmetry, or the line of symmetry. And you can actually see, by folding it, you can actually see that they're mirror images of each other. So that's good. We're going to, we've got the line, but I'm not going to cut it all the way down. What I'm going to do is I'm going to cut it along here for now, because we've got the line, that's what I wanted, and now we're going to cut it along there. I'm going to make one big triangle. Oh, maybe I should fold it a couple more times, because without scissors, you can actually, by the way, cut paper just by doing this again and again and again and again, and it will eventually just fall apart. That's another way of cutting paper. I haven't been very precise with this, so this won't be the most precise tangram. You can buy tangrams, you might even have a tangram in the house, but this is a way of really engaging. That's what happened with Ray this morning. he's not ever been, he's 5 and he's never really engaged with the Tangram, but once he had bits of paper, he got really into it. So just goes to show, oh dear, that wasn't very good there, was it? It just goes to show that being able to have your hands on manipulating things is a very engaging way of doing maths, which is, in my model of the world, that wouldn't stop when you're, as you get older, you would continue using manipulatives in the maths classroom. So we've now got 2 identical triangles. They're the same size. We've got one smaller one. So we could simply make loads. Remember, we were doing that other smaller one with this, which is a scale model of that one. It's not half the area of that one, but it is a scale model. It's the same proportions. That's another important conversation. The scale model, all the proportion between the length of the edges has to remain the same, and so the shape is the same. It's a different size, but the shape is the same. So it's not just a different type of triangle, it's the same type of triangle. The angles are exactly the same, just the lengths are different, and the proportion between that edge and that edge is the same as the proportion between that edge and that edge, but the lengths are different. And the same goes for this little chap that we created with the rectangle. Right, so now we've got 2 triangles, 3 triangles there, and now we've got a trapezium. So you can, again, talk about what can we make with the trapezium? What does it look like? What do you know in real life that looks like this? You can move it around and find different ways. Oh, it's one of those surfboards. You can just find different ways of identifying real life things of that same shape. Now, I like this one. What shapes can you make? What 2D shapes, what polygons can you make out of this trapezium? Now, it's definitely more than one. Right now we've got a trapezium, but we're going to break it into multiple polygons. So what can you imagine we could make? There's lots of different ones we can make, and we're going to see, like, we're going to start with, we've got to, and let me see, we're going to take this top vertex here, and we're going to lower it down. Is that the one we're going to do? No, that's not it. No, that's not it. Oh, I can do this, I can do this. It must be that there. Oh yes, there it is. Take that one from here and down to the bottom, so that line follows the centre line that's marked. And kerpow, kerbang, and I could do 2 of those, so you could have, ooh, it's becoming a nice shape too, very nice. So that is a parallelogram. So we can make one, we're going to make 1 parallelogram, but you could have made 2, as you can see. And what else can you make out of this? So we've got the parallelogram. We're going to I hope you're doing a better job of ripping these off than me. Right, so we've got a parallelogram. We can have a conversation about that. You've got 2 opposite parallel lines. Now, again, when you're studying for your exams, like when you're 14, 15, 16, you can actually see, you can test the angles, because they get asked about all these angles and what is that angle with respect to that angle. And you can actually see, well, if you put that angle, you can make 2 of these and see that if you combine the 2, that, make another one, and you'll find that that plus that is 180 degrees. And the other interesting thing is, you can, if you add that, and that, how many degrees have you got? Now, if that plus that is 180, I'll let you work that out. And that's another nice exercise that we will do at some point, is to see what happens as you add an extra edge or an extra angle onto a polygon. What happens to the total, the sum of the angles, both inside and outside. It's some nice, it's nice people maths you can do there as well. Once we can all actually get together and play together again, some really nice people maths. We'll be doing that once we can get people together in the same room. Right, now, the next one is Whoops. Oh dear, dear, dear. What's left of this poor thing. Not a very good job there. But what was left of that to lead up to the fold, well, we didn't have to do that. We could have maybe, I don't know what else we could have made, but if we'd left that on, see what other shapes you could make, and see if, for example, you can make another one the same as that. I don't know. You've got to look, and you can actually then test to see, are all the edges the same, are all the angles the same, by literally putting them against each other. Now, that is another point. Those two angles are the same of the triangle and the of that particular parallelogram. Right, so now we've got a very sad looking what's left. So how many shapes can we make out of this? Can we make 2 shapes? Can we make 3 shapes? What 3 shapes can you make out of it? What shapes can you make out of it? Okay, what I'm going to do for my Tangram is I'm going to now fold this in half across here. And it's a very sad shape. I did a much better job this morning. It's a very sad shape here. And oh, I've done a rubbish job of this. But anyway, here we go. So in theory, these 2 smaller triangles that came from that trapezium are the same, in theory. I haven't done a very good job. And then we've also got a square. How can we tell it's a square? Fold it in half. We have, again, 2 identical triangles which are symmetrical along the axis. And then what can we do with it? We can make art. We can make art. We can make art based on just triangles, or we can make art based on all these shapes. You can make other shapes. See what shapes you can make out of this. See if you could, what angles. See if we maybe make 2 triangles out of that. What angles would they make? You can just really experiment and make some lovely art out of it. And not just that, we will be doing this at some point in the not too distant future. How many polygons can you make out of it? So the challenge is to make a polygon, and of course the very first thing you've got to do is put all of these back together to make the square, the intact piece of paper that we started off with. So that first square that we started off with, this size, your first task is to, remake all those pictures like a puzzle back into that original square. And then you can make all these polygons. There's so many things. You can Google lots of things, lots of shapes that you can make. There's a sort of nice symmetrical shape there that you can make. You can make a kitty cat. There's loads. You can get books and books and books of Tangrams. There's another one. There's a few here. Have I got that one on here as well? Yes. No. I've got the Running Man. I like this one. Got the Running Man. That one there. So, oh look, that gives you the crib sheet. Oh, don't look now, don't take a screenshot, for goodness sake, don't take a screenshot, no! It's gone. And so there's now what else can we do with Tangrams? The discussions that we can have around the Tangrams is you're looking at the symmetry, and then you can look for other things. You can look for, because you've got shapes, you've got a tangible shape that's not precious. You can make it again. You can make it again and again and again and again. You can make different shapes. You can cut up different shapes and explore how all the shapes relate to each other from another square. You can, of course, make paper airplanes and other things. And then you can look at symmetry in real life, symmetry of your body. Stand behind a mirror, and at one end of a mirror, have the mirror here, and with one eye, look and see, or take a picture of what you look like with yourself reflected in the mirror. You can just look and see in the world around you when you walk out in parks and things, or just Google it, watch movies, spot all the just stick with symmetry, have conversations about symmetry. Oh, here's some more Tangrams for you to do. Examples. There. But there are loads. I had books when I was a kid of all the different Tangrams. It was quite hard work. Now let's see questions. you can ask things like, what do you notice? What do you notice about a pattern? What do you notice about the shapes? How many different shapes can you see? What are the shapes called? Look at triangles. We've got how many different triangles? We've got 1, 2, 3 triangles. Well, there's 4 and 5 triangles in all. So what is the same and what is different about all these triangles? And then we've got this other triangle you could make out of the rectangle. Is that the same? Is that triangle there the same or different to any of the other triangles? And what is the same and what is different? And what can you find? What else can you find that's symmetrical? Draw the things that you find that's symmetrical. Yeah, where is the mirror line? Where is the, so if it's a 3D shape, you can have the axis of symmetry. You can look at rotational symmetry. So I've got my lamp here, for example. If I rotate, you can see it. You can put it around like that. You can see it that way. If I rotate it there, from your perspective, does it look exactly the same? No, it doesn't. If I rotate it there, does it look exactly the same? No, it doesn't. So with rotational symmetry, it doesn't look the same from your perspective. But let's say if we just looked at that line there, just the line, don't look at the top and the bottom, that, pretend it's straight. That is basically a cylinder. That has, well, an infinite amount of symmetries because it's circular, it doesn't have any edges. You can just look at and examine all kinds of things. So this, now that is a mirror image of that, but only through there. So this bit at the back here kind of messes with it, but you can look at that. That would be the mirror image of that along a plane. It wouldn't be so much, it wouldn't be along an axis, but along a plane. You could have a mirror there. So you could just have discussions like that. And, oh, I've got another one. Not the lid, but that's a nice shape you've got lots of symmetries with. I'm going to take the lid off. I'm going to have a sip. I'm thirsty. You can rotate that. That's basically got the shape itself, not the pictures on it. It's got an infinite amount of symmetries. It looks the same no matter where you're rotating it. So you can have it, I'm saying it's got an infinite amount of symmetries. You really want to have that conversation and say, well, how? Don't say it, ask it, and have discussions about it. Philosophical conversations about mathematics. Right. To let you know, the timings of the evening session are going to be changing. I'm going. This is a new thing anyway. I'm going by popular request. I'm doing one tonight because I said I would. We're finding out what works and what doesn't, and what people want and what people don't want. So we're just going with the flow, flowing with the go, and we might end up doing a 5 o'clock or so, 5 or 6 o'clock instead, so that the people on the west coast of the US and the American continent. I might do one in Spanish as well. That's a possibility. Who knows? Porque si hablo español, so es posible que lo haga. I might do one in Spanish. I haven't worked that one out yet. But thank you very much for joining me. I will be putting the links to the Maths Toys YouTube channel, Bubbly Maths YouTube channel. So Maths Toys give links specifically to the instructions for and links to the resources that will help you do more formal maths, more school maths. And then the Bubbly Maths is talks like this that are more, it's also got performances on it and things on the Bubbly Maths. And then there's the Aiming High site, so there'll be a link to activities you can do on Aiming High, which are again more formal. You've got the actual, there's a thing in my face, the actual resources to these resources right here. The link to those under this once the live is finished. Thank you very much for joining me, and see you again at the next one. Will be tomorrow 9 AM London time, and then there's going to be one tomorrow There isn't going to be a 5 o'clock tomorrow, so I'll probably do another 8 o'clock tomorrow, and maybe next week start with the 5 o'clock. Have a great morning, noon, mid-afternoon, evening, wherever you are in the world. Thank you for joining me. And I've got to stop this, so I've got to work this out.